a sentence or of a paragraph or whatever it may be, where we're going to use the string token function. And we haven't talked about string toke, have we?
No.
Okay. It's one of those really nice little functions that are available to you in C, C++. There's these that are available, string string, string char, and they all require the C string header. There's also these others, memset, memcopy, memcompare, memmove, and memchar. Those are all of a general class of functions available to you for doing string kinds of operations. String toke takes two things. One, it takes a pointer to a string, and that string will be some long thing, and a delimiter, a pointer to a delimiter, should be a character type of delimiter. In our case, it's going to be a character, a space. So what string toke does is really kind of interesting and kind of fun. It takes a null terminated string and a set, either one or more, null terminated C string, one or more characters to be looking at as delimiters. And it will return, each time we call it, it will return a pointer to the next token. So in case of this lab, we start off pointing here to the I, and string toke then, after we call it a second time, would give us a pointer to don't, and so on. When no more tokens are found, then null is returned by string toke. Call to string toke, one is here and the other is here, and the interesting thing about string toke is that the parameter, this text title, for example, is maintained across multiple calls to string toke. It is an example of a static variable, Now, Kenan, what is a static variable?
It doesn't change. Like once it's declared, it doesn't change.
Once it's declared, it stays the same. What about if we place it in a call to a subroutine and leave the subroutine? When we come back to the subroutine, what happens to the pointer? It is what it was left as. Okay, when we declare a pointer to be static, we would have that pointer, that value, left after the call. So in some ways it acts like a global variable, so its value is always there. And some ways it acts like a local variable in that the value is not accessible outside of the function definition. So when we make this call to string toke, text title is considered by string toke to be a static variable, and the pointer, even though it's changed upon exit, is maintained so that the next time it's called, that pointer is available, that next location is available. So here we have a way to walk down this string, and since this is a space, we will break it apart by spaces and output each of the tokens in turn. Is that clear? Questions with how that works? We're going to do that until string toke has a null. So we're going to stop when string toke returns a null. Okay. That's one thing we want to keep in mind. Then, moving forward here in the notes, I'm going to start to look at ragged edged arrays. And this is the first slide in that section on ragged edged arrays. Some concepts that we want to think about. How many bytes are actually allocated for name2? It's going to be 6 bytes allocated for name2 because this is a string constant. Those same or similar 6 bytes allocated and assigned to name3. The address is assigned to name3. So the picture looks kind of like this, where this one is pointing over here, dynamically not dynamically allocated, but statically allocated because we initialize it that way. The first one had 10 as the length allocated, and we had some waste of space here, waste of allocation space. And so the idea here of a ragged edged array is this one, where we have an array of pointers to character strings, and each of these character strings is exactly the required size based upon the string length. We could have, you all understand, I hope, that a two-dimensional array like char name could also be used to store Bill, Bob, and George, right? We could store these things in this fashion, but the difference is that in this case, the previous case, since this is a char star, this is an array of pointers, and each of these is exactly the required amount, whereas this wastes a lot of space. Is that clear? Now, the amount of space savings, you'd say, well, that's not very much. It's not much worth doing this until we do something like this. Well, what name is going to be longer than 200? Well, probably not many, but let me extend that for you. And make this an int. Do you suppose it's possible to have a matrix that size?
Yeah.
Yeah. Now, do I have enough memory to do that? Each integer is 4. Well, let me just, I want a little bit more accuracy, so let me make it a double. Do I have enough memory to do that? And if I now want to do another one,